In the coldest weeks of the Arctic winter, when the night stretches on for 20 hours and the air can freeze exposed skin in seconds, even a modern expedition tent struggles to stay livable. Yet centuries before synthetic fabrics and titanium stoves, Inuit hunters built snow houses that didn't just keep them alive. They kept them warm enough to share meals, tell stories, and celebrate the winter feast. To outsiders, it looked impossible. A home made entirely from snow in temperatures that plunged to 50 degrees. But the igloo was never a simple dome. It was an engineered structure born from generations of observation. Builders searched for the perfect wind-packed snow, cut it into blocks that locked together like stone, and shaped a spiraling dome strong enough to stand against 100-mile-per-hour gusts. Inside, airflow, raised sleeping platforms, and a tiny cold trap entrance created a microclimate so efficient the temperature could rise more than 60 degrees. How did Inuit hunters turn frozen water into one of the most effective passive heating homes ever built? Part 1. In the vast, frozen expanse of the Arctic, where the winter landscape stretches endlessly in shades of white and blue, and where temperatures can plummet to 50 degrees below zero Fahrenheit, the Inuit people have thrived for thousands of years. This is one of the most inhospitable environments on Earth, a place where survival requires not just courage and endurance, but a profound understanding of the natural world. At the heart of the Inuit winter survival strategy lies a structure that is both an architectural marvel and a testament to human ingenuity: the igloo. This is not the cartoonish hemispherical dome of popular imagination, but a sophisticated engineered dwelling that could be built in a matter of hours and yet provide a safe, warm, and comfortable home through the darkest, coldest months of the year. The word igloo in Inuktitut simply means house, but to the Inuit, it represents something far more significant. It is a dwelling made entirely from snow, a material that most people associate with cold and discomfort. Yet, in the hands of a skilled builder, snow becomes the foundation of warmth and shelter. The igloo is a structure that works with the laws of physics, not against them, harnessing the insulating properties of snow to create a microclimate that can be 40 to 60 degrees Celsius warmer than the frigid air outside. This is the story of how Inuit hunters built these remarkable snow houses and how they created spaces warm enough not just to survive, but to celebrate life in the heart of winter. Our journey begins with an understanding of snow itself. To the untrained eye, snow is simply frozen water, a uniform white substance that blankets the landscape. But to an Inuit hunter, the snowpack is a complex layered material with a wide range of properties and characteristics. The selection of the right snow is the most critical step in building an igloo, and it requires years of experience and a deep, intuitive knowledge of the Arctic environment. The ideal snow for igloo construction is wind-packed snow, known as Pukak in Inuktitut. This is snow that has been compressed by the relentless Arctic winds into a dense, uniform slab, strong enough to be cut into blocks, and yet still filled with countless tiny air pockets that give it its remarkable insulating properties. The Inuit developed specialized tools to assess the quality of the snow. The hovgut, a long metal rod with a small ball at the tip, is used to probe the snowpack, revealing its depth and consistency. A skilled builder can read the resistance of the snow as the rod is pushed down, identifying the layers and determining whether the snow is suitable for construction. The snow must be at least a meter deep, and it must be free of the weak, sugary layers that can form within the snowpack and cause a structure to collapse. Once the perfect patch of snow is found, the construction can begin. The building process itself is a masterclass in efficiency and precision. Using a snow knife called a panna, traditionally made of bone or ivory but now often fashioned from metal, the builder marks out a circle on the snow. This circle will become the footprint of the igloo, and its diameter will determine the size of the dwelling. A small igloo for a single hunter on a short trip might be only 2 meters in diameter, while a larger family igloo could be up to 5 meters across. For communal gatherings and celebrations, several igloos might be linked together to create a spacious multi-room structure capable of housing dozens of people. The builder begins by cutting blocks of snow from within the marked circle, carving a trench that will eventually become the interior floor of the igloo. Each block is approximately 1 meter long, half a meter high, and 20 centimeters thick. The first row of blocks is laid around the perimeter of the circle, and then the true artistry begins. The builder creates a sloping ramp by cutting the top of the first row at an angle, and from this point forward, the blocks are laid in a continuous, inward-leaning spiral. This spiral construction is the key to the igloo's structural integrity. Each new block is placed on the one below it and shaped with the panna to fit perfectly against its neighbors, creating a seamless, self-supporting dome. The builder works from inside the igloo, the structure rising around them as they carefully shape and position each block. Part 2. The construction of an igloo is not merely a matter of stacking blocks of snow. It is a sophisticated engineering process that requires an understanding of geometry, structural mechanics, and thermal dynamics. The spiral construction method is crucial because it allows the dome to be self-supporting at every stage of the building process. Unlike a traditional arch, which requires temporary support until the keystone is in place, the igloo's spiral design means that each block is immediately locked into position by the blocks around it. This allows a single builder to construct an igloo alone without the need for assistance or scaffolding. As the walls rise, the builder continuously adjusts the angle of each block, ensuring that the dome curves inward at the correct rate. The blocks must lean slightly inward, creating a catenary curve that distributes the weight evenly across the entire structure. This is the same principle that gives strength to arches and domes in stone architecture. But the igloo achieves it with a material that is far lighter and more flexible than stone. The final block, the keystone, is a carefully shaped plug that is dropped into the hole at the top of the dome. With the keystone in place, the structure is complete, a perfect, seamless hemisphere of snow. The builder then cuts a small doorway at the base of the igloo and crawls out. But the construction is not yet finished. The entrance to the igloo is a critical component of its thermal design, and it requires careful attention. The entrance tunnel is built low to the ground, often extending several meters from the main dome. This tunnel serves a crucial function. It acts as a cold trap, preventing the warm air inside the igloo from escaping and the cold air outside from entering. The principle is simple but effective. Since cold air is denser than warm air, it sinks to the lowest point. By building the entrance tunnel below the level of the main living area, any cold air that enters the igloo will pool in the tunnel, unable to rise into the warmer space above. The warm air inside the igloo, being lighter, stays trapped in the upper part of the dome, creating a stable, stratified temperature gradient. The interior of the igloo is then finished with the same attention to detail. A raised platform of snow is built at the back of the igloo, elevated above the floor level. This platform, known as the Igleq, will serve as the main living and sleeping area. It is covered first with a layer of twigs or branches, and then with thick caribou hides, creating a warm and comfortable surface. The elevation of the platform is crucial for maintaining warmth. Since warm air rises, the warmest air in the igloo is in the upper part of the dome. By sleeping on a raised platform, the inhabitants position themselves in this layer of warm air, well above the colder air that pools on the floor and in the entrance tunnel. A small hole is poked in the roof of the igloo to provide ventilation. This hole is essential for allowing fresh air to enter and smoke to escape if a fire is lit inside. Without this ventilation, the buildup of carbon dioxide from breathing could become dangerous. In some igloos, a block of clear freshwater ice is set into the wall to create a window, allowing the faint light of the Arctic winter to filter into the interior. This ice window is carefully selected for its clarity and transparency, and it provides just enough light to see by during the brief daylight hours of the Arctic winter. The entire construction process, from finding the right snow to completing the interior, can be accomplished in as little as 2 to 3 hours by an experienced builder. This speed is essential in the Arctic, where weather conditions can change rapidly, and the ability to quickly create shelter can mean the difference between life and death. But the igloo is not just a temporary emergency shelter. It is a carefully engineered dwelling that can serve as a comfortable home for weeks or even months, providing warmth, protection, and a space for family and community life. Part 3. The ability of an igloo to maintain a warm interior in the face of extreme cold is a result of a sophisticated interplay of physics and design. The Inuit, through generations of observation and experimentation, developed a deep, intuitive understanding of the principles of heat transfer, insulation, and convection, and they applied this knowledge to create a dwelling that is a marvel of thermal efficiency. Modern scientists, studying the igloo with the tools of contemporary physics, have confirmed what the Inuit have known for millennia. The igloo is one of the most energy-efficient structures ever devised. The primary reason an igloo stays warm is the insulating property of the snow itself. Snow is not a solid material, but rather a matrix of ice crystals with a vast amount of air trapped between them. In fact, compacted snow can be up to 95% air by volume. This trapped air is a very poor conductor of heat, which means that it is an excellent insulator. The thick walls of the igloo, typically 20 to 30 centimeters thick, create a formidable barrier to heat loss. The heat generated inside the igloo, primarily from the body heat of its occupants, is trapped within the structure, unable to escape to the cold outside air. The temperature difference between the inside and the outside of an igloo can be astonishing. Even with no fire, the body heat of a few people can raise the interior temperature to a level that is 40 to 60 degrees Fahrenheit warmer than the outside. If the temperature outside is minus 45 degrees Fahrenheit, the temperature inside can reach a relatively comfortable 15 degrees Fahrenheit or even higher. With the addition of a small fire, fueled by seal oil burned in a stone lamp called a Igleq, the interior temperature can rise to 60 degrees Fahrenheit or more. This is warm enough to live comfortably, to cook food, to dry wet clothing, and even to celebrate a winter feast. The igloo's dome shape also contributes significantly to its thermal efficiency. The curved surface minimizes the amount of surface area exposed to the cold wind, reducing heat loss through convection. The dome shape is also incredibly strong, able to withstand the weight of heavy snow accumulation and the force of strong Arctic winds. The strength of the dome comes from the way the blocks are arranged. Each block is supported by the blocks around it, and the weight of the structure is distributed evenly across the entire dome. This means that the igloo can support a tremendous amount of weight without collapsing, and it can withstand wind speeds of up to 100 miles per hour. As the igloo is occupied and heated, a remarkable transformation occurs. The heat from inside the igloo causes the inner surface of the snow blocks to melt slightly. This meltwater then refreezes, creating a thin layer of ice on the interior walls. This ice layer seals any cracks or gaps between the blocks, making the structure airtight and further improving its insulating properties. This process is similar to the air sealing that is done in modern homes to improve energy efficiency. By preventing air from leaking in or out, the ice layer ensures that the heat generated inside the igloo stays inside and the cold air outside stays outside. The design of the igloo's interior is also crucial for maintaining warmth. The raised sleeping platform, or Igleq, is positioned in the warmest part of the igloo. Since warm air rises, the upper part of the dome is significantly warmer than the floor. By sleeping on a raised platform, the inhabitants are in this layer of warm air, well above the colder air that pools on the floor. The entrance tunnel, with its cold trap design, ensures that this stratification of air is maintained. Any cold air that enters the tunnel is trapped in the low point of the U-bend, preventing it from flowing into the main living area. The result is a stable, comfortable temperature that can be maintained with minimal energy input. Part 4. Life inside the igloo was a world away from the harsh, frozen landscape outside. It was a world of warmth, community, and celebration, a testament to the resilience and adaptability of the Inuit people. The igloo was more than just a shelter from the cold. It was a home, a place where families lived, worked, and celebrated together through the long, dark winter months. The interior of the igloo was a carefully organized space designed to maximize comfort and efficiency. The focal point of life inside the igloo was the raised sleeping platform, or Igleq. This was the main living area, a space for sleeping, eating, and socializing. Covered with warm caribou hides, it was a comfortable and inviting space, and it was here that the family would spend most of their time. During the day, the family would gather on the Igleq to work on their tools, sew clothing, and tell stories. The women would prepare food, often cooking seal meat or fish over the kulak, the stone lamp that provided both heat and light. The men would repair their hunting equipment, sharpen their knives, and plan the next day's hunt. The children would play games, learn traditional skills, and listen to the stories of their elders. At night, the family would sleep huddled together on the Igleq, their shared body heat adding to the warmth of the igloo. The caribou hides provided insulation from the cold snow platform, and the thick fur kept the family warm even on the coldest nights. The kulak would be kept burning through the night, providing a steady source of heat and a comforting glow of light. The small ventilation hole in the roof would allow the smoke to escape, ensuring that the air inside the igloo remained fresh and breathable. The winter was a time for community. With the hunting season at a lull and the sea ice making travel difficult, families would often build their igloos close together, creating a small village of snow houses. These winter villages were centers of social life, places where families would visit each other, share food, and celebrate together. Sometimes large communal igloos, or kagik, would be built for gatherings and celebrations. These could be massive structures up to 15 meters in diameter, created by linking several smaller igloos together with connecting tunnels. Inside the kagik, the community would come together for feasts, dances, and games. The most important of these winter celebrations was the Kuviasukvik, the Inuit winter feast. This was a time of great joy and spiritual significance, a celebration of the new year and the return of the sun after the winter solstice. The Kuviasukvik was a multi-day festival filled with feasting, dancing, and traditional games. It was a time to give thanks for the past year's hunt, to honor the spirits of the animals, and to ask for good fortune in the year to come. Historical accounts from early European explorers provide a fascinating glimpse into the traditions of the Kuviasukvik. In 1864, the explorer C.F. Hall observed the festival among the Nugumiut people of southern Baffin Island. He described how the community would gather in a large snow house on a certain evening, and how the Igloos, or shaman, would lead the people in prayers for public prosperity through the subsequent year. This would be followed by a great feast, with everyone sharing the food that had been hunted and preserved during the fall. The next day, the entire community would go out into the open air and form a circle. In the center of the circle would be a vessel of water. Each member of the community would bring a piece of meat, and each person would eat their meat in silence, thinking of Sedna, the goddess of the sea and animals, and wishing for good things. Then, one by one, each person would take a cup, dip it in the water, and drink, thinking of Sedna. Before passing the cup to the next person, each would state audibly the time and place of their birth. This ceremony would be performed by all in succession, from the oldest to the youngest. After the ceremony, presents of various articles would be thrown from one person to another. The idea was that each person would receive good things from Sedna in proportion to the liberality they had shown. Then 2 men would start out, one dressed to represent a woman, and they would go to every house in the village, blowing out the light in each. The lights would afterwards be rekindled from a fresh fire, symbolizing the renewal of the sun for the year. This ritual represented the belief that the sun was renewed each year, bringing new light and new life to the Arctic. Part 5. The world of the traditional Inuit igloo, with its intricate construction and its deep connection to the rhythms of the Arctic, is a world that is rapidly changing. The introduction of modern building materials, heating technologies, and a more settled way of life has made the igloo a less common sight in the Arctic landscape. Today, most Inuit live in permanent wood frame houses in established communities with modern amenities like electricity, running water, and central heating. The knowledge of how to build an igloo, once a fundamental survival skill passed down from generation to generation, is now in danger of being lost. In Nunavut, one of Canada's fastest-growing regions, the demographic shift has been dramatic. Nearly 60% of the region's population is under the age of 25, and many young people have never learned the traditional skills of their ancestors. Modern hunters often pitch a tent rather than building an igloo, finding it faster and more convenient. The ability to build an igloo has become rare, and it is now considered unusual to rely on this traditional shelter. Yet, as elders and community leaders point out, knowing how to build an igloo could save a land user's life if they are stranded without a tent or cabin. The need for these traditional survival skills is more pressing than ever. Every year, more than 250 search and rescue missions are conducted in Nunavut, a region with a scattered population of just 37,000 people. This means that every 2 days, someone gets lost in the wild, a rate that has more than doubled in the past decade. Many of these stranded individuals are victims of equipment failure or lack of proper safety gear, unable to afford the satellite phones or new parts for all-terrain vehicles that could prevent such emergencies. In this context, the ability to quickly build an igloo from the snow around you is not just a cultural tradition, it is a potentially life-saving skill. The Arctic is also changing in ways that make traditional knowledge even more valuable. Over the past 30 years, land temperatures in the north have risen nearly 2 degrees Celsius, and the old ways of predicting weather are in transition. In the past, hunters and fishermen could read the skies to prepare for an incoming storm, but now, elders say, the winds come too fast and too strong. The region has reported changes in wildlife movement, thinning ice, and rising sea levels. As one community leader put it, Inuit tradition is adapting to the environment, and the igloo, as a symbol of that adaptive tradition, remains relevant. And yet, the legacy of the igloo endures, not just in the Arctic, but around the world. It lives on in the stories and memories of the elders, in the cultural revitalization programs that are working to pass this knowledge on to a new generation, and in the enduring lessons that the igloo offers to the modern world. In an age of growing concern about climate change and the need for more sustainable ways of living, the igloo stands as a powerful symbol of human ingenuity and a model of energy-efficient design. The principles of the igloo, the use of local natural materials, the harnessing of passive heating, the importance of insulation and airtightness, are the very same principles that are at the heart of the modern green building movement. The igloo is, in effect, the original passive house, a structure that can maintain a comfortable interior temperature with little or no external energy input. Architects and engineers today are studying the design of the igloo, looking for inspiration in its elegant simplicity and its profound understanding of thermal dynamics. Some modern buildings incorporate design elements inspired by the igloo, such as curved roofs that shed snow and wind, thick insulation that traps heat, and entrance vestibules that act as cold traps. The igloo also offers a powerful lesson in resilience and adaptation. The Inuit did not try to conquer the Arctic or bend it to their will. Instead, they learned to live in harmony with it, developing a way of life that was flexible, adaptable, and deeply respectful of the natural world. The igloo was a key part of this adaptive strategy, a dwelling that could be built quickly and easily wherever it was needed, using only the materials that the environment provided. As we face the challenges of a changing climate, with its increasingly unpredictable weather and its growing threat to our settled ways of life, the Inuit model of resilience and adaptability has much to teach us. But perhaps the most important legacy of the igloo is its reminder of the importance of community. The igloo was not just a house, it was a home, a place where families and communities came together to share their lives, their stories, and their warmth. The celebration of the Kuviasukvik in the heart of the winter was a powerful affirmation of the bonds of community, a recognition that survival is not just about physical warmth, but about social and spiritual connection. In our modern world, with its emphasis on individualism and its growing sense of social isolation, the image of a community gathered together in a large, communal igloo, sharing a feast and celebrating the return of the sun, is a powerful and moving one. The snow house of the Inuit hunter is more than just a historical curiosity or a relic of a bygone era. It is a testament to the enduring power of human ingenuity, a model of sustainable design, and a powerful symbol of the importance of community and connection. It is a story that is written in the snow, a story of survival and celebration, of hardship and joy, of tradition and adaptation. It is a story that has much to teach us about how to live in a changing world and how to find warmth, light, and celebration in the heart of the darkest winter. The igloo is a reminder that the most profound solutions are often the simplest, and that the key to a sustainable future may lie not in new technologies or complex systems, but in the rediscovery and reapplication of ancient wisdom.